Well, everybody, we're halfway done with the semester. So when we get started here today, we're going to review what we ended up doing last time. Rationals and radicals. You're the third person here. No, we were talking about, there's almost 12:30. Nobody's here. I was coming down. I didn't see nobody here. We had to check our phones to make sure it was Wednesday. No. If I ever miss a class, I will always send a reminder. So that's for sure. So if you don't get a message from me, I'm either running late or even if I'm running late, I'll send a message. So that's why I love remind. Okay, so how do we solve this problem? On the LCD, right? All right, because it's fractions and equal sign. So what's the LCD in this case? Well, even before the LCD, you have to do something else. Anybody remember? Not really. This is step 0. Factor denominators. Because we don't know what the LCD is, because we have a lot of squares and stuff like that on the bottom. We can't have that. So we have to factor out the denominator. Then we'll know what the basic functions are of our denominator. So first, factor the denominators. What can factor out of the first one? 2, 4. So we take out a 4, what do we have left? So yeah, divide both these by 4, so we have x plus 3. And how about this one? What does that one factor out into? Nope, it's got a square, can't. Oh, so it's x minus the x. It's a difference of 2. Is 9 a squared number? What times what equals 9? Yeah, so this is x squared minus 3 squared. It's called the difference of 2 squares. So that means it's x and 3, one's plus, one's minus. It's the difference of 2 squares. And the last one is itself. It's x minus 3. And there's a 4. So the LCD is 4, x plus 3, x minus 3. Right. And you saw that. They're either x plus 3, x minus 3. So that's the common term on the bottom. So that's the reason we factor whenever you have rational equations and x is on the bottom, factor them out. So you see what the LCD is going to be. And then second step after that, multiply the LCDs. So I have to take this LCD and put it in front of each of my terms. One over 4 x plus 3 minus 4 times x plus 3 x minus 3 times 1 over x plus 3 x minus 3 5 over x minus 3. That's the hardest part because it's a lot of writing. And if you miswrite something or omit something, it'll give you a bad answer. So this, it takes a lot of space But once we get past this curve, it's simple. Yeah, so now we reduce. So the 4 cancels. The x plus 3 cancels. All we have left is x minus 3 times 1. What cancels in the second one?
Both of them.
Yeah, x plus 3, x minus 3. So we're left with 4 times 1.
Wait, what? 4 times 1?
This is the 4, and there's 1. And the only thing cancels in the last one is the x minus 3. There, it's a lot easier looking now. From this one, yeah, it's now we're in easy street. Fourth step, multiply to get rid of the parentheses, and then solve. So x minus 3 times 1 is simply x minus 3. Negative times positive is negative. 4 times 1 is 4. 4 times 5 is 20. 20 times x is 20x. Positive times positive. 20 times 3 is 60. Because this is actually.
Now I'm confused. Where did you get the 4 from?
This 4?
Yeah.
Well, the LCD is x plus 3, x minus 3, and a 4.
Oh, okay.
Whatever's on the bottom is your pieces. Yeah, because it has to cancel. If you don't cancel out the 4, it's still down there. So you need to get rid of all denominators. Combine like terms. X minus 7 equals 20x plus 60. Which one do you move?
Move the 60 to the left side.
No.
Why not?
Because what are we solving for?
X.
X is the important thing. Do we have all the x's on one side?
No.
So which x do you move? The smaller one. This is 1x. So how to get rid of the 1x? Subtract 1x. So we have negative 7. 20 minus 1 is 19x plus 60. Now we have all the x's to one side. Now we get rid of the 60. Get rid of anything that's not an x. So it's negative 67 equals 19. Divide 19 by both sides. Does 19 go into 67?
I don't think so.
I don't know. Let's try it. Let's try 3. 19 times 3. 9 times 3 is 27. 3 times 1 is 3. Plus 2 is 57. So it goes in there 3 times with 10 left over. Is it a valid answer? How do we know? Well, you could check, but remember last time I told you a shortcut. we could look at the original equation and set these equal to 0 and see, well, we have our LCD. What's the only x's we cannot use? What would make these 0? What would make x plus 3 equal 0 if x is what? So it cannot be -3. Well, this would be 0. So x cannot be 3 or -3. Anything else works. That's not 3 or -3, so it works. That's our answer. You want to try another one? So we got to factor out the denominators. From there, we can find our LCD with both x plus 2's and x. Okay. So I put the LCD in front of each term. Then I reduce. The x plus 2 is gone. The x is gone. The x and x plus 2 is gone. So I have x times 3x, x plus 2 times 6, 1 times 12. So now next step is multiply to get rid of the parentheses. X times x is x squared. 6 times x, they're both positive, 6x. Positive times positive is positive. 6 times 2 is 12. 1 times 2 is 12. It's quadratic, so it has to equal what for us to solve it? 0. So we have to get rid of this one. And that cancels also. So what do you do next? All the x's to one side. How do you solve that? 3x squared plus 6x. Last week we talked about if we had a binomial, we had 2 terms and they both have x's. What do you do with it? Can you factor it?
Oh, yeah.
Since everything has x at least, we know we can factor something out. So what do they both have in common? They both have a 3, and what else? They have 1x at least. So if I divide both of these by 3x, so I factor it out, the 3 disappear. 1x disappears, so I have x. X is 6 divided by 3 is 2. Then what do you think we have to do? There's no moving. We have it set equals 0. We're down to linear equations. There are no more squares anywhere. If you have two numbers or two terms multiplied together that equals 0, what has to be true? If two things multiplied equals 0, what has to be true about these guys?
One of them has to be 0, right?
One of them has to be 0, or they both have to be 0. Since we don't know which one, we set them both equal 0. And work them out. Again, this is stuff we did. I need you guys to stay current in your homework, because the closer you stay to where we are here, the more sense this stuff will make. And it's going to save you a lot of time in chapter 4. And chapter 5 is easy. It's less difficult than chapter 4, but it's still going to be complex. It's logarithms and exponentials. Divide both sides by 3. So x equals 0. And subtract 2, x equals -2. So what do we do next? Look at your original equation. What x's can we not use?
Right?
Yeah. Take your denominators, set them equal to 0. So I can't use a -2. I can't use a 0. So I cannot use these two numbers. That's both of them. So I have no solution. That's what it means. There's another property when it comes to factoring. We know the difference of two squares now. If we have this difference of two squares, what does that factor out into? It has to have opposite signs, because notice there's no middle term. So the middle term has to cancel. That's the difference of two squares. We have two more. The sum and difference of two cubes. The only difference between these two equations are the first two signs. It's going to have A and B in both of these, A and B. So if the equation is plus, that goes in the first box or parenthesis. If it's a minus, that goes in the first one. In the second parenthesis, notice everything else is the same. The only thing different is with these two. That sign is the opposite of the first sign. So if that's a plus, this one's a minus. And the last one's always a plus. If that's a minus, this one has to be a plus. That's the only difference between the two, are the first two signs. The first sign is what's inside the equation. The second sign is the opposite of that one. We can solve this one. This one, we cannot solve. It'll give you imaginary answers. So example. Is that a difference of 2 cubes? Is that a difference of 2 cubes? What is 8 made up of? 2 times 4, and that's, so it's 2 times 2 times 2. In other words, it's 2 cubed. So it's the same thing as x cubed minus 2 cubed. So it is a difference of 2 cubes. So in the first parenthesis, it's just that, whatever's under the cubes. So it's x, in this case, minus 2. Remember, this number here is A, and that is B. So remember, it's A squared, so it's x squared. What sign? But it's the opposite of this one, so positive. 2x, because it's A and B, plus 2 squared. X squared plus 2x plus 4. And there's your factored form. Okay, so whenever you see one of the terms is a cubed, to see automatically if the second one is a cube. Does that one satisfy that condition?
Oh yeah, one cube is one.
1 cube is 1, yeah. So that's where a lot of people mess up that question right there, because they think, no, it's only 1, 1. No, it's the same thing as that. Good catch. So this one becomes x plus 1, because it's whatever is under the cubes goes inside the first parenthesis. We know the signs are going to be minus and plus inside here. The second sign is always plus. Whatever the first term is, square it. Whatever the last term is, goes back here and you square it. And they multiply to go inside here. X times 1 is x. Or 1x if you want. You can put 1x. So that's how you factor cubic equations. The reason I showed you this is because obviously you know it's going to be an example with that. x or 8 over x squared minus 2x plus 4 equals x over x plus 2 plus 24 x cubed plus 8. So this one's already factored. Can't go any further. Can this one go any further? What times what is 4? When you add them, you get 2. Two times 2 is 4. 2 plus 2 is 4.
It can't be.
That one can't go any further. Is this one? It's got a cube. So is this a sum of 2 cubes? What's 8 made up of? Yeah, so this is x cubed plus 2 cubed. Which means we can factor this one out using the rule we just learned. What goes in the first parenthesis? Yeah, it's whatever's under the cube. So it's x plus 2. Inside the second parenthesis, x squared, sign, minus 2 times x, 2x, plus 2 squared, which is 4. You notice how this one looks like that one. So the LCD is it's x plus 2, x squared minus 2x plus 4. X plus 2, x squared minus 2x plus 4 times 8 x squared minus 2x plus 4 equals x plus 2 x squared minus 2x plus 4 times x over x plus 2 plus x plus 2 x squared minus 2x plus 4 24 x plus 2 x squared minus 2x plus 4. So obviously, yeah, once we cancel this stuff out, it gets smaller really quick. X squared minus 2x plus 4 cancels, leaving us with 8 times x plus 2 equals the x plus 2 cancels. X times x squared minus 2x plus 4. All this stuff cancels, equal plus 24. Yes, it got small really quick. Get rid of the parentheses. 8x, 8 times x is 8x, positive, positive, positive. 8 times 2 is 16. X times x squared is x cubed, Positive times negative is negative. X times 2x, 2x squared. Positive times positive is positive. X times 4 is 4x plus 24. The hardest part of this equation problem so far should have been the factoring of the cubes. That's the hardest part. Everything else is cancellation. We haven't done anything else except multiply. Now what do? We have to say it equals 0 because it's a polynomial. If it has a power, then we have to set it equals 0. Everything after linear equations sets equal to 0. So we subtract 8x from both sides. And we subtract 16. So it's 0 equals x cubed minus 2x squared. 8's bigger, so it's minus. 8 minus 4 is 4x. 24 minus 16, 24 is bigger, so it's plus. 24 minus 16 is 8. Four terms. We learned last week, if we have 4 terms, how do we solve that one? Well, what's the best way we know how to solve it so far? Grouping. Remember the grouping method? That's where we set parentheses in the first two and the last two, including that minus sign in the middle. Now, what can we factor out of the first one? Just one x? Yeah, they have 2 x's each, so we can take out 2 x's. If we take out 2 x's out of the first one, we only have 1 x left. And take out 2x out of the second one, we only have a 2 left. How about the second one? What can we factor out of there? Because that's a minus, we have to take away the negative sign, which means it's going to change the signs inside there.
4.
And a 4. So if we divide each of these by -4, that becomes a positive x and a -2. Yeah, because positive and negative. You took out a -4, so you divide each of these by -4. The 2 negatives cancel out here. That's why it's positive. Positive and negative is a negative. 8 divided by 4 is 2. Now what can you factor out? Because we have 2 terms, we can take out the x plus 2 or x minus 2, which means you always put the coefficients into the second one. X squared minus 4. How can that one get factored out? Look at both these numbers. It's a minus sign. There's a square. So what rule are we going to look at? See if it works. The difference of 2 squares. Is 4 a perfect square? Made up of what? 2. So it's x squared minus 2 squared. Difference of 2 squareds. Which means it factors out into what? X plus 2, x minus 2. You should have a sheet of all the rules that we go over in this class next to you when you do the work and study. You should go through all your notes and write a formula sheet. I used to give them out, but they didn't tell the students to do anything themselves. I did all the work for them. You guys have to do that. So what are my answers? Set each of these equal to 0, solve them. Now these are solutions. This one equals 2. This one equals -2. And this one equals 2. So remember, when you're solving, it's always the opposite sign inside the parenthesis. So our possible answers are 2 and -2. Are there any that we can't use from the original equation? Look at the original equation. Look at the denominators. Are there any x's that make them 0? This we can't factor, so we don't have to worry about this. How about this one? We cannot equal -2. So that means out of all of our answers, the only thing we can use is x equals 2. That's our only answer we can use. All right, I'm going to need you guys to do some homework on those alone instead of me doing them all the work for you. So again, it's not a viewing spectator sport. How would you solve that one?
No solution, right?
Why?
There's a -4 in there.
You can have a -4 inside an equation.
Under the, what's it called?
Radical. You can have a -4 inside there. You're trying to solve for x, right? So where's the x located? Inside the radical. Is the radical isolated by itself? Nothing else around it, in front of it, behind it, below it? So it's isolated. So we have to get rid of it. How do you get rid of it? Square both sides. The square root and the square cancel. 1 squared is 1. Add 4 to both sides. And divide by 3. Or 3 goes into 5 once with 2 left over. When you check it, it's always easier to check it with the improper fraction. So anywhere see an x, we put a 5/3. The 3's cancel. So we have 5 minus 4. 5 minus 4 is 1. Square root of 1 is 1. So our answer is correct. Radical 2x plus 1 plus 3 equals 4. Subtract 3, because we have to isolate the radical. 4 minus 3 is 1. Then, yeah, since it's isolated, get rid of it. Square both sides. 2x plus 1 equals 1. Subtract 1 from both sides. So 2x, 1 minus 1 is 0. Divide by 2. X equals 0. Check your answer. Two times 0 plus 1 plus 3 equals 4. 2 times 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. 1 plus 3 is 4. So x equals 0 is our solution. Will it always be no solution if it equals something negative?
Yeah.
When you said no, when will it not be? Let's see here. There. First step.
Okay.
Subtract 8 from both sides. It's negative. 8 minus 5 is 3. What do you do next? Cube it. Why cube it? Yeah, because there's a cube right there. So we have to cube both sides. Since that's a negative in front of the 3, I have to put parentheses around it. 6x plus 9. Negative 3 cubed is what? Negative 27. 3 times 3 times 3. Negative. Minus 9. 6x equals negative 36. They're both negative. Add the two numbers. Divide by 6. X equals negative 36 divided by 6 is 6. Again, we have to check our answers. Remember, our equation was 6x plus 9 plus 8 equals 5. So we put a negative 6 in place of x. 6 times negative 6 plus 9 plus 8 equals 5. 6 times negative 6 is negative 36 plus 9 plus 8 equals 5. Negative 36 plus 9. Negative 27. Cube root of negative 27. Negative 3 plus 8 equals 5. Because since it's an odd root, I can have a negative answer. Only odd roots can have negatives inside. Negative 3 plus 8 is 5. 5 equals 5. So our answer is negative 6. Let's put x's on that side. X plus 7 equals x plus 1. Is the radical isolated? Yes. So we do what? Square both sides. Since this is an equation, we have to put parentheses around it. We have to square both of these. So x plus 7. What happens to the right-hand side? No, but what that means is x plus 1 times x plus 1. We have to multiply those together. So x times x is x squared. X times 1 is x. X times 1 is x. 1 times 1 is 1. So it's x squared plus 2x plus 1. Now what do you do? Has to be equal to 0. So you have to move the x plus 7. Subtract x from both sides. And subtract the 7 from both sides. So 2x minus 1x is since 2 is positive, it's bigger. 2 minus 1 is 1, x. 7 is bigger than 1, it's negative. 7 minus 1 is 6. What signs go inside there? Why? Because the second sign is a minus. Very good. That means they're opposite signs. Where does the bigger number go? Yeah, the bigger number goes to the plus. So what times what is 3? When you subtract them, you get 1. Yeah, 3 times 2, 3 minus 2. So the bigger number gets the plus, the smaller number gets the minus. And what do you do from there? Yeah, we set them both equal to 0. So it's going to be x equals negative 3 and x equals 2. Oh, those are our answers? We're going to always check them. I mean, they could be, I don't know. So our equation was x, square root of x plus 7 equals x plus 1. Let's look at it both ways. X equals negative 3, x equals 2. So we have negative 3 plus 7 equals negative 3 plus 1. Negative 3 plus 7 is 4. Square root of 4 is 2. Negative 3 plus 1 is negative 2. Does 2 equal negative 2? So it can't be negative 3. Two plus 7, the square root of 2 plus 7 equals 2 plus 1. 2 plus 7 is 9, equals 3. Square root of 9 is 3. So the only answer we have is x equals 2. Again, I need you guys to practice these on your own. It's easy when I do it, but I need you to try it yourself. All right, let's finish up this chapter. We're now going to solve equations and inequalities that deal with absolute values. So for equations, we have absolute value of x equals a. If absolute value of x equals a, and I drop the absolute value of around the x, what values can x have to make it equal a? In other words, if I gave you this, what can x be to make that a true answer? Right. So x can be a positive or a negative 3. Because if I put a negative 3, absolute value is 3. If I put a positive 3 in there, it's 3. Let me look for some. I'll mix them up. Solve that. You have to isolate the absolute value, so we get rid of first. Subtract 3 from both sides. If I drop the absolute value, what happens to the 2? If I drop the absolute value, what happens to the a? It becomes a positive or negative. So it can be a positive 2 or a negative 2. That's why you have to look at both of them. X plus 2 equals a positive 2. X plus 2 equals a negative 2. Subtract 2 from both sides on both equations. 2 minus 2 is 0. Negative 2 is negative 4. And if you check your answer, 0 plus 2 absolute value plus 3 equals 5. Negative 4 plus 2 absolute value plus 3 equals 5. Plug them in there. Let's check them out. 0 plus 2 is 2. Absolute value of 2 is 2. 2 plus 3 is 5. So x equals 0 is a valid answer. Absolute value of -4 plus 2 plus 3 equals 5. So -4 plus 2 is, since 4 is bigger, it's negative. 4 minus 2 is 2. Plus 3 equals 5. Absolute value of -2 is 2. Plus 3 equals 5. 2 plus 3 is 5. 5 equals 5. So they both work. So that's how you do equations with absolute values. Isolate the absolute value, drop them. Can absolute value ever equal something negative? No. So if an absolute value equals, if you had an absolute value of x equals -2, no solution. It's impossible. Because absolute values cannot equal negatives.
Does it really not matter if it's a positive or negative, like as an end result
in the answer?
Yeah.
But it doesn't matter, because when you put it inside the equation, the absolute values get rid of the negative sign. So that's the important thing. It can be a positive or negative for the final answer. I can see why you think it wouldn't be, but remember, it's absolute value, not absolute equation. It's all works down to that one value. Okay, so the equations are easy. Inequalities and absolute values. As you can guess, there are two different types of equations here for inequalities. You have absolute value of x is less than a, or absolute value of x is greater than a. Depending on which direction you're looking at, it'll give you different answers. Let's look at graphically. Remember, what does an absolute value really tell us? An absolute value tells us the distance from 0 to that number. So like the absolute value of -3 is what? 3, because it's 3 units away from 0. It's 3 to the left, yes, but it's still 3 units. So that's all it tells us is a distance. So it all stems from 0. So remember, when we drop that absolute values, we can have positive and negative a. You have to look at both sides. But since x is less than a, it goes from a to 0. In other words, it goes from the number to 0. So if you have less than, if absolute value of x is less than a number, x is between negative a and positive a. So if I drop the absolute values, I get that equation, because it has to be between those two numbers. Make sense? So if you look at it that way, it makes sense, I hope. Here's a, here's negative a. If it's greater than, it's going away from x. It's going to infinity. So if the a is going to infinity, where's the negative side going? To negative infinity. So it's going away. So this one, greater than, has two answers. X is greater than a, or x is less than negative a. Let's look at this example. Absolute value of 3x plus 2 is less than 5. What form is this in right now? Since you have inequalities, is it set form, interval form, or graphing? This is set form. So let's put it in the other two forms. Let's solve this and put it in the other two forms. Let's graph it and then put it in interval notation. Remember, intervals deal with brackets and parentheses. So, is the absolute value isolated?
Yeah.
Yes. So if I drop the absolute value, what happens to this? Right. So whatever's inside the absolute value sits in between positive and negative 5. Because if it's less than positive 5, that means it has to be greater than negative 5. Again, now we will only worry about the middle. Whatever we do to the middle, we do to the outer two sides. Subtract 2 from everybody. They're both negative. 5 and 2 is 7. 2's cancel, so we have 3x. 5 minus 2 is 3. Get the x by itself, I got to divide by 3. So negative 7 over 3 is less than x is less than 1. There's your set notation. How would you graph it? Remember, when you graph it, you look at your endpoints. What are your endpoints?
So x would be negative 7.
Yeah, negative 7 over 3 and 1. Are they open circles or closed? Yeah, they're both, since they don't have lines, they're both open, and x is between there. That's the graph. Interval notation looks at your graph and sees the endpoints. So we have negative 7 over 3, comma 1. And since they're open, that means they're both parentheses. Let's try another one. Absolute value of x plus 6 is less than or equal to 10. Since it's less than or equal to, I'm going to drop the absolute value, what happens?
Positive negative 10.
Yeah, it has to be between positive and negative 10. So it's whatever's inside the parenthesis goes to both sides because it's less than. If it's greater than, it's a different picture. Subtract 6 from everybody. negative 16 is less than equal to x is less than equal to 4. The graph of this, what are my endpoints? Open or close circles? Yeah, because they're equal sign equalities, they're closed, and x is between there. That's where x is. So my interval notation will be where? So what will numbers be? I start at negative 16 and go to 4. Parentheses or brackets? Absolute value of 2x plus 8 is greater than equal to 18. All right, now it's greater than. So when I drop the absolute value, what happens to it? What's it going to look like? But now how is it going to be situated? Yes, it's always going to be positive and negative, but is it going to be negative 18 less than equal to?
Negative 18 is greater than.
Remember our equation. If it's greater than, that means it has to go away from it. So x is bigger than a. Or if it's negative a, it has to go away from 0. So x is less than negative a. So we have 2x plus 8 is less than or equal to negative 18. Or 2x plus 8 is greater than equal to positive 18. We have to look at both directions. Has to be less than negative a or greater than positive a. Subtract 8 from each term. 2x is less than equal to negative 26. Or 2x is greater than equal to positive 10. Divide by 2. Divide by 2. X is less than equal to negative 13. Or x is greater than equal to 5. What's the graph going to look like? So we start at negative 13. Open or close circle? Which direction does it go? To the left. And then the positive 5 also closed. This one goes to the right. So this one goes to negative infinity. This one goes to positive infinity. Why is that important? Because remember, the interval notation looks at the beginning and the ending of x. So these are your x's. So in this part, where does it start? Negative infinity, and it goes to negative 13, which is a bracket. Unioned with, it starts off at 5, it's a bracket, and it goes to positive infinity. And that's how you do it. That does it for chapter 3. Actually, 3.5 is it's like maybe 2 or 3 pages long. And that was it. And there weren't that many examples either. Should we start chapter 4 or not? Nah. Okay, we'll call it a day. Call it a week. We've done chapter 3.